Hello, this is Chris Cassidy of the Dutchess County Hazmat Team. In this short video, we're going to go over the use and applications of the onboard chemical library in the Multi-Rae Pro. We'll also see the different responses we get on the Pro when testing chemicals of different relative strengths. The Multi-Rae Pro has an extensive library of chemicals, over 200 for the PID sensor and over 50 for the LEL sensor. The chemical we'll be testing today is acetic acid. The main ingredient in household vinegar. Household vinegar strength varies between 5 and 10% by volume. In this case, approximately 5%, with most of the remainder as water. I also have it in a more concentrated form, glacial acetic acid. Glacial acetic acid has a concentration of greater than 80%. If you're interested, you can get this from a science website. From the NIOSH Pocket Guide, we'll take a look at some of the pertinent properties of glacial acetic acid. With a strength of greater than 80%, the DOT number is 2789. Its permissible exposure limit is 10 ppm. IDLH is 50 ppm. Molecular weight is 60. Flash point 103 degrees Fahrenheit. LEL is 4%. Vapor pressure is 11 millimeters of mercury. And the ionization potential is 10.66 electron volts. Physical description is either a colorless liquid or a crystal with a sour odor. An interesting property of glacial acetic acid is its melting point of 62 degrees Fahrenheit. My garage temperature is in the 60s. You can see both solid and liquid phases in this bottle of glacial acetic acid. I have this one in a snow bath, and it is totally solidified. This one in a warm bath, totally liquid. Using these two tins to simulate a spill, we'll test how the meter responds when uncorrected. I have this tin already filled with vinegar. With a molecular weight of 60, most of the vapors should remain in the tin area. And you can see that in this case, the VOC PID indicator peaked at around 1000 ppb with the LEL at 0%. Putting some of the warm glacial acetic acid I'll get the glasses on first. Using the warm glacial acetic acid, please only use this in a well-ventilated place. We'll pour some of that into this sample here. And we'll get another sample. You can see the meter peaks at around 10,000 ppb, and the percent LEL still remains at 0. However, using the onboard library, we can get corrected readings for the acid directly. Press the mode and the N key to get to the program menu. Arrow over to measurement group, select. Arrow down to change measurement gas, select. Select VOC. Arrow down to gas library, select. Arrow down to acetic acid. Wait. You see the correction factor comes up for acetic acid at 22. Select. Save. Now we're going to go back to measurement again. I'm going to select, change measurement gas again, select, and then move down to the LEL sensor, select, go to the gas library, select, and again choose acetic acid. Select that. You see the correction factor for acetic acid is 2.5. We'll save. And then we're going to go back to measurement mode. Okay, now we're going to get a sample off of the vinegar. And we can see that the vinegar peaked at around 18,000 ppb, and the LEL still remained at 0%. We'll let the reading come down for a minute. Now we'll take a sample of the glacial acetic acid. And we can see that the PID VOC meter peaked at around 200 ppm. You can see how the ppb meter changed from the ppb scale to the ppm scale. The percent LEL meter never came off. So with that limited sample in there, it was not enough to change the meter. So it looks like quite a difference you can see. So to conclude, we can see the changes on our readings from weak versus strong acid strength and corrected versus uncorrected sensors. Now I'll return the sensors to their normal calibration measurement gas to bring the meter back to uncorrected mode. Hope you enjoyed the video. Goodbye.